Deep in the vastness of space, an extraordinary event is unfolding, one so rare that scientists can scarcely believe what they are witnessing. A cosmic phenomenon, unlike anything observed in modern history, is sending ripples through the solar system, and Earth is directly in its path. The effects are already being felt, and researchers are scrambling to understand the implications of what could be one of the most significant astronomical events of our time. At first, the signs were subtle. Instruments detected small but unusual fluctuations in the planet's electromagnetic field. Satellites picked up disturbances in the ionosphere, affecting communications and navigation systems in ways that defied conventional explanations. Then came the atmospheric anomalies, strange auroras appearing at latitudes where they had never been seen before, an unusual dimming and brightening of the sky, and temperature fluctuations that puzzled climatologists. Something was happening, but the cause remained elusive. As the anomalies grew more intense, scientists turned their attention to space. Telescopes and deep space monitoring systems were directed toward the heavens in an effort to trace the source of these disturbances. What they found sent shockwaves through the scientific community. A rare cosmic event, unseen for centuries, was unfolding on an unprecedented scale. One of the leading theories suggests that Earth is passing through an interstellar energy field, an immense cloud of charged particles that originated from a distant celestial event. Some researchers believe it could be the remnants of a nearby supernova explosion, a dying star that unleashed a torrent of radiation and cosmic energy. If true, this would mean that Earth is now moving through a region of space saturated with exotic particles, potentially influencing everything from weather patterns to human biology. But this is only one possibility. Others speculate that a massive, previously undetected celestial object, a rogue planet, a distant pulsar, or even an exotic type of dark matter, is exerting a gravitational and electromagnetic effect on our solar system. The implications of such a discovery would be groundbreaking, reshaping our understanding of the universe and our place within it. The most alarming aspect of this phenomenon is its unpredictability. Unlike solar storms, which follow a relatively known pattern of activity from the Sun, this event appears to be beyond anything Earth has encountered in recorded history. If it continues to intensify, the consequences could be profound. Already, scientists are seeing strange disruptions in the magnetosphere, the invisible shield that protects our planet from harmful cosmic radiation. If this disturbance grows stronger, it could lead to a breakdown in Earth's natural defenses, exposing the surface to heightened levels of radiation. The effects on technology could be catastrophic, with power grids, satellites, and electronic systems facing potential failure on a global scale. And then there is the possibility of direct biological effects. Some researchers are investigating whether the influx of cosmic radiation could have subtle but significant impacts on human health. Could these high-energy particles alter DNA, increase mutation rates, or even influence brain function in ways we don't yet understand? The answers remain unclear, but history has shown that cosmic radiation has played a role in evolution and genetic adaptation over long periods. If Earth is truly passing through a region of enhanced cosmic activity, the effects might not be immediate, but they could shape humanity's future in unexpected ways. As researchers work tirelessly to unravel the mystery of this cosmic event, one thing is certain: we are witnessing something unprecedented. Never before has Earth encountered an interstellar disturbance of this magnitude in the age of modern science. Every new discovery raises more questions than answers, and the scientific community is racing against time to decipher what this phenomenon means for the planet, for life, and for the very nature of the universe itself. And this is only the beginning. Scientists are still gathering data, running simulations, and preparing for what may come next. Could this event be a precursor to something even larger? Are we on the brink of discovering new cosmic forces that could redefine our understanding of physics? Or is this simply a natural cycle of the universe, one that Earth has experienced before but was never able to record? The answers may be just beyond our reach, hidden in the vastness of space. But one thing is certain: the universe is far more mysterious, far more powerful, and far more unpredictable than we ever imagined. And we are only just beginning to understand its true nature. The deeper scientists delve into the data, the more perplexing the situation becomes. Observatories across the globe, from Chile's Atacama Desert to Hawaii's Mauna Kea, are detecting unusual fluctuations in cosmic radiation levels. Space agencies, including NASA and the European Space Agency, have deployed their most advanced instruments to analyze the strange energy signatures emanating from deep space. Even space telescopes like Hubble and the James Webb Space Telescope are being redirected to search for an explanation. At the heart of this mystery lies an anomaly so bizarre that it challenges the very foundations of astrophysics. Some researchers believe Earth may have wandered into an interstellar energy stream, an invisible ribbon of charged particles coursing through the galaxy. These streams, also known as cosmic filaments, are thought to be remnants of massive galactic-scale events, such as black hole mergers or the explosive deaths of stars in distant supernovae. If Earth has indeed entered such a region, the effects could be unlike anything recorded in human history. For centuries, civilizations have looked to the sky for guidance, interpreting celestial events as omens or signs of cosmic shifts. But unlike ancient astrologers, modern scientists have tools that allow them to measure these events with incredible precision. The problem is that this particular phenomenon defies easy classification. Unlike known cosmic threats such as solar flares or asteroid impacts, this anomaly is subtle yet far-reaching, manifesting in ways that hint at a complex interplay of gravitational, magnetic, and quantum forces. One of the earliest indicators of this cosmic disturbance was the sudden shift in Earth's upper atmosphere. The ionosphere, a crucial layer that facilitates radio communication and shields the planet from space radiation, has been experiencing unprecedented fluctuations. Shortwave radio operators first noticed strange signal disruptions, which were later confirmed by satellite data. In some regions, the ionosphere has expanded and contracted unpredictably, disrupting global positioning systems, GPS, and even causing minor blackouts in communication networks. Auroras, typically confined to the polar regions, have been appearing at unusual latitudes, stretching into areas that rarely see such light shows. Some scientists believe this could be due to charged particles from deep space interacting with Earth's magnetic field in ways we have never observed before. If the influx of high-energy cosmic rays continues, we could see an increase in atmospheric disturbances, with possible effects on weather patterns, climate regulation, and even aviation. As theories continue to emerge, one of the most controversial yet intriguing possibilities involves dark matter. This elusive substance, which makes up the vast majority of the universe's mass, remains one of the greatest mysteries in modern physics. Though dark matter has never been directly observed, scientists detect its influence through gravitational effects on galaxies and galaxy clusters. Now, some researchers are questioning whether Earth may have encountered a dense pocket of dark matter, an anomaly that could be distorting local space-time and generating unexpected energy signatures. If this hypothesis is correct, it would be the first direct evidence of dark matter interaction with ordinary matter, potentially revolutionizing our understanding of the cosmos. However, without concrete proof, the idea remains speculative, and many physicists urge caution before jumping to conclusions. One of the more immediate concerns for scientists is the impact this phenomenon could have on Earth's magnetic field. The planet's magnetosphere acts as a protective shield, deflecting harmful cosmic radiation and preventing solar storms from wreaking havoc on the surface. However, recent observations suggest that the magnetosphere is experiencing anomalies that defy standard models. In certain regions, the field appears to be weakening, allowing an increased influx of cosmic rays into the upper atmosphere. This has led to concerns that a prolonged exposure to this rare cosmic phenomenon could increase the risk of radiation exposure for both astronauts and airline passengers traveling at high altitudes. Some scientists worry that if the magnetic field is disrupted further, it could trigger geomagnetic storms that might interfere with power grids, satellites, and other critical infrastructure. As Earth continues to experience the effects of this rare cosmic event, some astronomers are looking beyond the immediate vicinity of our solar system for clues. Observations from deep space telescopes indicate that other celestial bodies, perhaps even entire star systems, may be experiencing similar anomalies. One particularly intriguing discovery is a distant neutron star that has been exhibiting strange pulses of energy, seemingly in sync with some of the disturbances detected on Earth. While it is still unclear if there is a direct connection, some researchers believe this neutron star could be acting as a cosmic beacon, its signals influenced by the same interstellar forces currently affecting our planet. Another possibility is that Earth has entered a high-energy region of the Milky Way, possibly aligning with the galaxy's spiral arms in a way that exposes us to new cosmic conditions. If this is the case, the effects we are seeing now may only be the beginning of a longer, more complex cycle of cosmic interactions. With so much uncertainty surrounding this event, governments and scientific institutions are working to determine what, if anything, can be done to mitigate potential risks. Space agencies are ramping up their monitoring efforts, launching new probes and satellites to gather more data on the cosmic disturbances. Meanwhile, astrophysicists are developing computer models to predict how long these anomalies might last and whether their effects will intensify over time. In the short term, the biggest concern is how this phenomenon could impact technology and infrastructure. If the disruptions to the magnetosphere worsen, we could see an increase in satellite malfunctions, GPS failures, and even damage to power grids. Some experts warn that without proper preparation, this could lead to widespread blackouts and communication breakdowns, disrupting everything from global commerce to emergency response systems. In the long term, the implications of this event could be even more profound. If Earth is truly passing through an interstellar energy stream or encountering a new form of cosmic radiation, it could force us to rethink fundamental aspects of physics and space travel. Could this phenomenon offer new insights into the nature of the universe? Could it unlock technologies we have yet to imagine? For now, all we can do is observe, analyze, and prepare. The cosmic forces at play are beyond human control, but our ability to study them has never been greater. With each passing day, new data is being collected, bringing us one step closer to understanding the true nature of this rare and extraordinary event. And yet, the deeper we look, the more we realize how little we truly know about the vast and mysterious cosmos that surrounds us. Scientists are now expanding their search beyond our planet, looking to the very fabric of space itself for answers. Some astronomers believe this rare cosmic phenomenon could be linked to distortions in the space-time continuum, subtle warps in reality that ripple across the universe like invisible waves. If true, this could mean that Earth is temporarily caught in an anomaly, a region of space where the fundamental forces governing physics behave differently than expected. The implications of this are staggering. If space-time itself is bending or fluctuating in ways we've never seen before, it could explain the bizarre gravitational shifts, the unusual atmospheric reactions, and even the strange patterns observed in cosmic radiation. Could Earth be passing through the wake of a long-gone celestial event, perhaps the aftershock of a distant supernova, or the gravitational footprint of an unseen interstellar object? This brings us to an even more mind-bending possibility. What if the source of these anomalies isn't something natural at all? A growing number of physicists are exploring the idea that what we're witnessing might be the result of an advanced civilization's technological footprint. Some theoretical models suggest that highly advanced extraterrestrial societies, if they exist, could manipulate space-time itself, creating disturbances that ripple across the cosmos. Could an advanced intelligence be conducting experiments on a scale so massive that its effects are reaching Earth? While this idea is purely speculative, it isn't entirely without precedent. Scientists have already proposed concepts such as the Kardashev scale, which categorizes civilizations based on their ability to harness energy. A Type 3 civilization, one capable of controlling an entire galaxy's energy output, could theoretically leave behind gravitational waves, unusual radiation signatures, or even modifications to the cosmic background itself. If we are detecting such signatures now, it could mean we are glimpsing the aftereffects of an intelligence beyond anything we can comprehend. Meanwhile, another group of researchers is investigating whether this cosmic anomaly is influencing Earth's natural cycles in unexpected ways. Strange fluctuations have been recorded in ocean currents, as if unseen forces are subtly altering the planet's climate systems. Even the jet stream, a key driver of weather patterns, is behaving unpredictably, shifting in ways that don't align with normal atmospheric physics. Some experts believe this could be an indirect effect of space-weather interactions, where charged particles from the anomaly are disrupting Earth's upper atmosphere in ways we have yet to fully understand. On the biological front, reports are surfacing of unusual animal behaviors that coincide with the rise of this cosmic event. Certain migratory species, such as whales and birds, which rely on Earth's magnetic field for navigation, have been exhibiting erratic movements. Entire flocks of birds have been observed changing direction mid-flight, as if sensing something humans cannot detect. Could it be that Earth's natural life forms are more attuned to subtle cosmic forces than we are? And if so, what are they responding to? Further complicating matters, astronomers have discovered a puzzling change in the light signatures of distant stars. Some of these stars, which have remained stable for centuries, are now showing unexpected dimming and brightening patterns, behavior typically associated with planetary transits or massive objects passing through interstellar space. However, the timing of these anomalies is suspiciously aligned with the strange occurrences here on Earth. Could there be a direct link? If so, it raises a question no one wants to ask: is Earth simply an observer in this rare cosmic event? Or is our planet somehow an active participant? Could we be caught in a vast interstellar process, something so immense and complex that we've only begun to grasp its edges? As data continues to flood in from observatories around the world, excitement and anxiety grow in equal measure. Some scientists see this as an unprecedented opportunity to expand human knowledge, to glimpse the mechanics of the universe on a scale never before possible. Others warn that we are dealing with forces we barely understand, forces that could have consequences beyond our ability to predict. Some scientists are beginning to entertain the possibility that this anomaly is part of a much grander cosmic cycle, one that has remained hidden from us until now. Could our solar system, in its constant orbit around the galaxy, be crossing through a region where space itself behaves in ways we have yet to fully understand? This hypothesis suggests that certain parts of the galaxy may experience brief but intense periods of cosmic turbulence, where magnetic fields, radiation levels, and even the flow of time itself could be altered by factors outside our current knowledge. If our solar system has entered such a region, it would explain the sudden onset of these strange phenomena: gravitational anomalies, cosmic radiation spikes, and erratic shifts in atmospheric conditions. For the first time, we might be witnessing the effects of a galactic phenomenon we never knew existed. However, what's even more shocking is the suggestion that this cosmic disturbance could be the precursor to an even bigger event, one that may not just affect Earth, but our entire solar system. Some astrophysicists are speculating that these unusual shifts in space-time could be setting the stage for something akin to a galactic event horizon. If this is the case, Earth might be caught in the gravitational influence of an unseen cosmic entity or object, its presence felt in the very structure of space-time itself. The search for such an entity has become an urgent priority for astronomers. Observatories have intensified their efforts to scan the skies, looking for any hints of a massive, invisible object lurking near our solar system, something capable of bending space and time on a scale beyond anything we've seen. One possibility is that we might be entering the outskirts of a dark star, a hypothetical stellar object that emits little to no light but exerts a gravitational pull strong enough to distort the fabric of space around it. If a dark star is indeed lurking just beyond our reach, its effects could explain the current cosmic disturbances we're experiencing. As part of this ongoing search, scientists are also focusing their attention on the behavior of neutron stars and black holes. These enigmatic cosmic objects are known for their extreme density and gravitational forces, which could potentially ripple through space in ways that affect distant regions. Imagine a powerful gravitational wave emanating from a distant black hole, traveling across billions of light years to arrive at our solar system. Such waves could create fluctuations in Earth's magnetic field, alter the flow of cosmic radiation, and even disrupt the stability of our atmosphere. At the same time, research into cosmic rays has opened up another intriguing avenue of exploration. These high-energy particles, which are typically produced in supernovae and other violent cosmic events, have been detected in abnormally high concentrations. Some scientists are now wondering if these particles could be part of a cascading effect triggered by a massive cosmic event. If cosmic rays are becoming more prevalent, could they be interacting with Earth's magnetosphere in ways we haven't observed before? Some experts believe the uptick in cosmic ray activity might even be a sign of something deeper, something we've only begun to scratch the surface of. There is a growing theory that our galaxy is in the midst of a cosmic transition, a shift that could reshape everything we know about the universe. This theory suggests that galactic dynamics are in flux, and the forces that govern the cosmos are changing. If true, this could explain the seemingly random disturbances we've been witnessing, the spikes in radiation, the fluctuations in gravitational forces, and the increasingly erratic behavior of Earth's weather patterns. As researchers continue to gather data, new instruments are being developed to probe these mysteries further. One such project involves creating a network of satellites that can track cosmic phenomena in real time, providing researchers with the ability to monitor changes as they happen. These satellites could help detect minute fluctuations in spacetime, allowing scientists to map out the extent of the disturbance and pinpoint its source. On a more immediate level, the effects of this cosmic anomaly are already being felt on Earth in unexpected ways. There have been reports of unusual fluctuations in GPS systems, as if the very fabric of spacetime is being stretched and compressed, causing distortions in satellite signals. Some satellites have even experienced sudden malfunctions, possibly due to exposure to higher than usual levels of radiation or gravitational waves. This has raised concerns about the vulnerability of our increasingly connected world. Could the same forces that are disrupting satellites also affect other technologies we depend on, such as communication networks, power grids, or even transportation systems? While these potential disruptions are concerning, they also point to something much larger, something that we are only beginning to comprehend. The more we learn about this rare cosmic phenomenon, the more it becomes clear that we are standing on the precipice of a new era of understanding. We may be witnessing the birth of a new branch of science, one that combines astrophysics, space-time theory, and advanced technology in ways never before imagined. In this new age, the lines between science fiction and reality may blur. The idea that cosmic forces are at work, subtly influencing the course of human history, may no longer be relegated to the realm of imagination. As we continue to gather data and refine our understanding, the answers to these questions may hold the key to unlocking secrets about the universe itself, secrets that have eluded us for centuries. The future of our planet, and of human civilization, may very well hinge on our ability to understand and adapt to these cosmic disturbances. Whether we are prepared for this new frontier remains to be seen, but one thing is certain: the universe has more in store for us than we ever could have predicted. As the cosmic phenomena unfold, there's an increasing sense that humanity is standing at the threshold of something truly transformative. Researchers are working tirelessly to process the data from multiple observatories and satellites, trying to decode patterns from the chaos of cosmic radiation and gravitational anomalies. Every new finding seems to add another layer of complexity to an already puzzling situation. It's as though we are being confronted with a cosmic riddle, and only by piecing together seemingly unrelated pieces of information can we hope to make sense of it. One intriguing theory suggests that these disturbances may be the result of a massive cosmic structure, perhaps even a colossal, unseen object, such as a rogue planet or a dwarf star, that is subtly affecting our solar system's stability. If such an object exists, it could be exerting an immense gravitational influence, warping the very fabric of space-time. Theories about such objects have been around for years, but only now, with advancements in technology, are scientists able to begin testing the feasibility of these ideas. In addition to this, another line of inquiry is the idea of a cosmic phase shift. Some scientists propose that space-time itself could be undergoing a transition, a shift that would fundamentally alter how we perceive the universe. Imagine a scenario where the very rules governing the cosmos were in flux, where the gravitational constants we've relied on for centuries were suddenly subject to change. Such a shift could have vast implications, not just for the Earth, but for the entire solar system. The impact of this transition could manifest in numerous ways, from unpredictable shifts in weather patterns to the destabilization of our magnetic field. Some experts believe that we may even be witnessing the early stages of such a shift. This cosmic phase shift could explain many of the strange occurrences we've been tracking, whether it's unusual auroras, heightened seismic activity, or the rapid shifts in cosmic radiation levels that have become increasingly apparent in recent months. To better understand these disturbances, some scientists are now looking back into the history of our planet and examining past cosmic events. They are seeking to determine if there were periods in Earth's history when the planet was affected by similar cosmic forces. While the Earth's geological record is full of clues, one of the most intriguing patterns scientists have discovered is a correlation between certain cosmic events and mass extinction events. Could these disturbances be part of a larger cosmic cycle that impacts the planet at regular intervals? If so, understanding the timing and nature of these cycles might give humanity the chance to better prepare for the potential dangers ahead. At the same time, advances in quantum physics are opening new avenues of exploration. Physicists are now beginning to hypothesize that the fundamental particles making up our universe might be more interconnected than previously thought. Some even believe that the strange phenomena we're observing could be the result of higher dimensional interactions, an interaction between the 3D world we experience and other, unseen dimensions that exist beyond our perception. This concept, which has long been confined to the realm of theoretical physics, is now being actively explored by researchers with new experimental tools and technology that could finally provide answers. Alongside these theoretical advances, there has been a growing push to develop new, more powerful technologies to monitor cosmic events in real time. We are entering an era where our ability to observe and understand these events may soon surpass anything we've seen before. Innovative tools like the next-generation space telescopes, capable of capturing clearer, more detailed images of distant cosmic objects, are poised to bring new insights into the phenomenon. These tools, in combination with artificial intelligence systems designed to sift through vast amounts of data, will provide humanity with unprecedented access to the workings of the universe. On a more immediate scale, the practical implications of these cosmic anomalies are already beginning to affect daily life. The sudden surge in cosmic radiation has led to unexpected disruptions in satellite communications, with some systems experiencing sporadic failures or glitches. Some industries are grappling with the effects of this radiation, as it interferes with the performance of certain electronic devices, from GPS systems to medical equipment. These issues are becoming more pronounced, and there is a growing concern that they could lead to further technological disruptions if the phenomenon intensifies. Scientists are working on ways to mitigate these disruptions, including researching new materials that can shield against cosmic radiation. Such innovations may be crucial as we move forward and rely even more heavily on satellite technologies. However, the challenge lies not only in protecting our existing systems but in adapting our technology to thrive in an environment where cosmic disturbances are becoming more pronounced. Meanwhile, some researchers are considering whether humanity can take proactive steps to shield the planet from the effects of this cosmic anomaly. There have been proposals for large-scale geoengineering projects that could involve manipulating Earth's atmosphere to create protective layers against cosmic radiation. While these ideas remain speculative and controversial, they highlight the sense of urgency in addressing the potential threats posed by the cosmic disturbances. What's particularly fascinating about this moment in history is that it's forcing humanity to reconsider its place in the universe. We've long thought of Earth as a stable, isolated sphere, with the laws of physics governing our lives in predictable ways. But the more we learn about these disturbances, the more it becomes apparent that our planet is not so isolated after all. The universe is a dynamic, ever-changing place, and we are witnessing the effects of forces that transcend our understanding. This realization could mark the beginning of a new chapter for human civilization, one where our relationship with the cosmos is no longer passive, but active. At the heart of this exploration is the recognition that we are still very much in the early stages of understanding the forces at work. While the data continues to pour in and new technologies are developed, it's clear that we are only beginning to scratch the surface of this cosmic mystery. The unknowns are vast, and the implications of these findings are far-reaching. But with each new discovery, humanity edges closer to unlocking the secrets of the universe, and in doing so, may find itself at the forefront of a new era of cosmic exploration. One theory that's gaining traction is the idea that this cosmic phenomenon could be linked to the increasing frequency of solar flares we've been experiencing over the last few years. These flares, often accompanied by coronal mass ejections (CMEs), are already known to cause disruptions in satellite communications, power grids, and GPS systems. But researchers suspect that the current surge in solar activity could be related to these disturbances, with the sun acting as a kind of amplifier, exacerbating the effects of cosmic radiation and altering Earth's magnetic field. What makes this so concerning is that solar flares themselves are unpredictable. While we can observe the sun and anticipate some level of solar activity, the magnitude of these flares and their corresponding effects on Earth remain a mystery. With the possibility of a larger, cosmic-scale event influencing solar behavior, scientists are scrambling to understand the implications this could have for our planet's long-term stability. The concept of cosmic weather is becoming more relevant in this context. Just like Earth's weather patterns, cosmic forces are constantly in flux. Whether it's the sun's activity or deeper cosmic phenomena, these forces interact in ways that are still poorly understood. For centuries, humanity's gaze has been fixed on the stars, but we've only begun to appreciate how intimately our planet is connected to the rest of the cosmos. The reality is that we may be more vulnerable to these cosmic forces than we ever realized. Despite the many challenges, there's also an element of awe that comes with studying such rare cosmic events. Scientists are faced with an unprecedented opportunity to explore the universe on a level never before possible. Advances in space telescopes and probes have allowed us to peer deeper into space than ever, capturing breathtaking images of distant galaxies, stars, and planets. These observations are providing valuable clues, not just about the phenomena affecting Earth, but about the nature of the universe itself. As we continue to explore the outer reaches of space, we're uncovering new, surprising phenomena. For example, the discovery of fast radio bursts, FRBs, has shaken the scientific community. These intense bursts of energy, coming from deep space, are still not fully understood, but they could be related to the same cosmic forces that are currently impacting Earth. Could FRBs be a distant precursor to the kind of disturbances we're seeing closer to home? It's a possibility that is now being explored by researchers. In tandem with these advancements in observational technology, there are new models of cosmic activity being developed to better understand the way in which various forces in the universe might interact. One such model proposes that gravitational waves, ripples in spacetime created by the movement of massive objects, could be playing a role in the current disturbances. These waves, which were first detected in 2015, are now a critical area of research as scientists attempt to understand how they might be affecting our solar system. Their subtle influence on spacetime could potentially have a significant impact on Earth's magnetic field and seismic activity. At the same time, there's an increasing focus on understanding the Earth's atmosphere itself, especially how it might interact with these cosmic forces. Some scientists theorize that the atmosphere could act as a shield, protecting life on Earth from the most harmful effects of cosmic radiation. However, as we've seen with the recent uptick in solar and cosmic activity, this natural shield is not infallible. In fact, there are growing concerns that we may be reaching a tipping point, where our protective atmosphere is becoming more vulnerable to disruptions from the cosmos. Perhaps one of the most fascinating aspects of all this is how little we actually know about the deeper forces of the universe. Even as technology advances and we discover more about the cosmos, the mysteries only seem to grow. We've only just begun to scratch the surface of understanding the universe's most fundamental processes, and each new finding brings more questions than answers. In the midst of all this uncertainty, humanity is faced with a crucial choice. Will we continue to look to the stars and explore the unknown, or will we retreat into a world that feels more predictable and secure? The answer to that question will likely determine how we respond to the cosmic disturbances affecting Earth. It's clear that these phenomena are not going away, and they may very well escalate in the coming years. But if we can harness the power of scientific discovery and technological innovation, we might be able to mitigate some of the risks and prepare for what lies ahead. The urgency of this endeavor cannot be overstated. Our understanding of cosmic forces is still in its infancy, and as we move forward, the stakes could not be higher. We are living in a time where every new discovery has the potential to reshape our understanding of the universe and our place within it. These cosmic disturbances are a reminder that Earth is not an isolated entity. It is part of a vast, interconnected web of cosmic activity that extends far beyond our planet. As researchers delve deeper into these cosmic phenomena, they're uncovering complexities that could transform how we view our place in the universe. One area of focus is the interaction between cosmic radiation and Earth's atmosphere. The more intense the radiation from these rare cosmic events, the more it challenges the integrity of our planet's protective layer. Cosmic rays, which are high-energy particles originating from distant stars, can have far-reaching effects on Earth's climate, weather, and even biological processes. While Earth's magnetic field does shield us from the worst of these rays, increasing solar activity and cosmic storms might test the limits of that protection. A key area of concern lies in the potential for disruptions in satellite communications and GPS systems. As these cosmic forces interact with Earth's magnetic field, they could induce geomagnetic storms that have the power to damage or even destroy satellites. This would have far-reaching effects, from impacting global communications to altering the navigation systems that guide everything from airplanes to autonomous vehicles. The importance of satellite technology in modern life cannot be overstated, and these cosmic disturbances represent an emerging vulnerability that could be difficult to mitigate. Moreover, the cosmic phenomena in question are prompting scientists to rethink the way they approach the study of space weather. The traditional models of space weather primarily focus on solar activity, such as coronal mass ejections and solar flares. However, these new disturbances could suggest that there are other, more mysterious cosmic forces at play, forces that might not be fully understood for decades, if not centuries. The fact that we are witnessing such a rare and unpredictable event underscores the need for further investment in space weather research. On a broader scale, these disturbances also highlight the fragility of life on Earth. While humanity has made remarkable strides in understanding the physical processes of our planet, we have yet to fully comprehend the intricate web of factors that influence our climate, weather, and ecosystems. Cosmic phenomena serve as a reminder that Earth is far from a stable, isolated environment. The forces at play in the universe are vast and often unpredictable, and they can influence Earth in ways that we are only beginning to grasp. Some researchers are exploring the possibility that these cosmic disturbances could lead to changes in Earth's geological processes. One theory suggests that the increased cosmic radiation might trigger volcanic activity, particularly in regions where magma chambers are already under strain. This would be especially concerning in areas known for active volcanoes, where the added pressure from cosmic forces could push the Earth's crust to the breaking point. While this is purely speculative at this stage, it adds an additional layer of uncertainty to the potential consequences of these cosmic phenomena. The complexity of the situation is compounded by the limitations of current technology. Despite the incredible advancements in space exploration and observation, scientists are still working with tools that only allow us to observe a small fraction of what's happening in the universe. For example, the telescopes and satellites we rely on to monitor cosmic activity are only capable of detecting certain types of radiation and signals. This means that there could be larger cosmic events happening that we simply can't detect yet, adding an element of unknown risk. As Earth's inhabitants, we find ourselves at a crossroads. On one hand, we are witnessing unprecedented advancements in our understanding of the cosmos. With each new discovery, we inch closer to answering some of the most profound questions about the universe. On the other hand, we are confronted with the sobering reality that we are still vulnerable to forces beyond our control, forces that could reshape our world in ways we can't predict. Despite the immense challenges posed by these cosmic disturbances, there is a sense of optimism within the scientific community. The fact that we are witnessing these events means that we have the opportunity to study them in real time and build a more comprehensive understanding of how the cosmos interacts with Earth. While there are many unknowns, the pursuit of knowledge has always been humanity's greatest strength. Our ability to adapt and innovate in the face of uncertainty will be critical in addressing the potential risks posed by these rare cosmic phenomena. At the same time, the urgency of the situation calls for greater collaboration across borders and disciplines. These cosmic events are not confined to one country or region, they are global in nature, affecting every part of the Earth. As a result, international cooperation in the field of space research is essential. By pooling resources, expertise, and data, scientists from around the world can work together to unravel the mysteries of these disturbances and develop strategies to mitigate their potential impact. In the coming years, we may see the development of new technologies aimed at better understanding and predicting cosmic events. Just as early astronomers used rudimentary telescopes to map the stars, today's scientists are harnessing the power of supercomputers, space telescopes, and advanced sensors to gain a clearer picture of the cosmos. With continued investment in space research, we may one day be able to predict cosmic phenomena with greater accuracy and, more importantly, develop methods to shield ourselves from their worst effects. However, while technology holds immense promise, it's important to acknowledge that we are still in the early stages of understanding the true scope of cosmic disturbances. The vastness of space, coupled with the complexity of the forces at work, makes it difficult to predict how these events will evolve over time. What we do know, however, is that our awareness of these phenomena is growing, and with that awareness comes the potential to mitigate some of the risks. The study of cosmic phenomena is not just about understanding the universe, it's about understanding ourselves. By observing the forces that shape the cosmos, we are also learning more about the fragile balance that sustains life on Earth. These disturbances serve as a reminder that our planet is not an isolated entity, but is intricately connected to the broader universe. And while we cannot control the forces that govern the cosmos, we can strive to better understand them, and in doing so, gain a deeper appreciation for the delicate balance that makes life on Earth possible. As the investigation into these rare cosmic events continues, scientists have started to develop some intriguing hypotheses about how these disturbances might interact with the very fabric of spacetime itself. One groundbreaking theory proposes that these cosmic phenomena could be linked to a phenomenon known as spacetime anomalies, localized distortions in the very structure of space and time. These anomalies are theorized to be small fluctuations in the fabric of spacetime that could be triggered by intense cosmic energy, such as the kind seen in supernovae or gamma-ray bursts. If these fluctuations can extend far enough, they might have subtle but significant effects on Earth, such as altered gravitational fields or changes in the passage of time itself. Such a phenomenon would explain some of the more bizarre observations associated with these cosmic disturbances. Some researchers have reported discrepancies in the timing of certain natural events, such as shifts in seasonal weather patterns or unexplained changes in the Earth's orbit. While it's still too early to draw any definitive conclusions, these anomalies could point to a deeper, more fundamental interaction between cosmic forces and Earth's natural processes than we've previously considered. It could also suggest that the universe operates in ways that transcend our current understanding of physics, pushing us to rethink even our most basic assumptions about space, time, and energy. One of the most exciting, though still speculative, ideas involves the possibility of a cosmic feedback loop. This concept suggests that as these disturbances propagate through space, they may not only affect the Earth but could also be amplified by the planet's own energy fields. In essence, Earth might be caught in a feedback loop with the cosmos, where each disturbance triggers a new wave of energy that spirals back into space, creating an ever-growing cycle of cosmic chaos. This could explain the increasingly frequent and intense nature of these cosmic events. Perhaps they are not random, but are, in some way, responding to conditions on Earth itself. To understand this better, scientists have begun to develop more advanced models of how cosmic radiation interacts with planetary systems. New simulations, run on some of the most powerful supercomputers in the world, are showing how particles from distant stars and cosmic events could travel through interstellar space and interact with the Earth's magnetosphere. These models suggest that when large bursts of cosmic radiation hit our atmosphere, they could alter the planet's natural electromagnetic field, which in turn could affect everything from the behavior of storm systems to the movement of tectonic plates beneath the Earth's surface. The full implications of this are still unknown, but it opens up an entirely new frontier of research into the relationship between Earth's environment and the broader cosmos. In addition to these groundbreaking ideas, there is growing interest in the potential role that dark matter might play in these cosmic disturbances. While still largely an enigma, dark matter is believed to make up a substantial portion of the universe's mass, even though it cannot be directly observed. Some theorists propose that these cosmic disturbances could be influenced by the interactions between dark matter and normal matter. This hypothesis is based on the idea that dark matter is not completely invisible, but rather that it can affect gravitational fields and other fundamental forces in subtle ways. If dark matter is indeed involved in these events, it could lead to the discovery of new, unknown physical processes that are currently beyond our detection capabilities. One of the more controversial but tantalizing theories gaining traction among researchers involves the concept of dimensional rifts. This idea suggests that these cosmic phenomena could be the result of interdimensional interactions, where energy or particles from parallel dimensions bleed into our own. While this might sound like science fiction, the mathematics behind this theory is grounded in the emerging field of string theory and the concept of multiple dimensions. According to string theory, the universe exists in more than the familiar 3 dimensions of space and 1 dimension of time. Instead, there could be as many as 11 dimensions, some of which might overlap with our own in ways that we cannot perceive directly. If such interactions are occurring, they might explain the irregular, unpredictable nature of these cosmic disturbances. The idea of dimensional rifts, while still in the realm of speculation, has opened up new avenues of research into the very structure of the universe. If these disturbances are connected to rifts between dimensions, it could mean that we are witnessing a type of cosmic event that is beyond our current ability to fully understand. Imagine the implications of such a discovery. We could be on the cusp of proving the existence of parallel universes, or even uncovering hidden laws of physics that govern the interactions between different dimensions. While such a discovery would be revolutionary, it would also require a complete rethinking of everything we know about reality. On a more practical level, scientists are working on improving our ability to monitor these cosmic disturbances in real time. Advancements in space telescopes, particle detectors, new frontier in the way we study the cosmos. If successful, QFAD could offer unprecedented insights into the fundamental nature of space, time, and energy. In the coming decades, we might see the development of a global network of such sensors, creating a real-time map of cosmic disturbances that could help us anticipate and mitigate their effects on Earth. A new breed of technology is being developed to better predict and understand their impact. One of the most promising innovations is the use of AI-powered simulations that can model the behavior of cosmic events with unprecedented accuracy. These advanced algorithms are designed to process enormous amounts of data in real time, identifying patterns and anomalies that might otherwise go unnoticed. By integrating data from a variety of sources, ranging from space telescopes to Earth-based detectors, these AI systems are capable of simulating how cosmic disturbances might unfold and how they could interact with our planet's atmosphere, magnetosphere, and even geological systems. These simulations allow scientists to test various hypotheses and predict the potential consequences of these disturbances, providing valuable insights into the ways they might affect Earth's climate, natural resources, and ecosystems. For example, some researchers are using AI to model how cosmic radiation might influence the growth of plants and animals, including the effects of potential genetic mutations triggered by intense radiation. Such predictions could help guide future agricultural and conservation efforts, preparing us for the potential biological impacts of these cosmic events. Moreover, these simulations are also being used to predict the potential effects on human infrastructure. For instance, satellite systems, power grids, and communication networks are all vulnerable to the impact of cosmic radiation and solar flares. By using AI to simulate how these systems might react under different conditions, scientists can better prepare for the worst-case scenarios and develop more resilient technologies to withstand the forces of these cosmic disturbances. On a broader scale, these simulations could even offer insights into how entire ecosystems might be affected. Some researchers are investigating the impact of cosmic radiation on ocean currents, weather patterns, and atmospheric composition. If these disturbances can alter the Earth's weather on a large scale, they could disrupt ecosystems in profound ways, leading to shifts in migration patterns, food webs, and biodiversity. This is particularly concerning in a time when global ecosystems are already under immense pressure due to human activities. With the increasing sophistication of AI and computational models, scientists are also looking to combine these digital simulations with physical experiments. For example, research teams are using particle accelerators to recreate the effects of cosmic radiation in a controlled environment. By bombarding samples of Earth's atmosphere, soil, and biological material with high-energy particles, they hope to better understand how cosmic radiation interacts with the Earth's natural systems. This research could pave the way for new materials, technologies, and processes that could help protect our planet from these cosmic forces. The role of the Sun in these cosmic disturbances cannot be overstated. As one of the primary drivers of space weather, the Sun is a constant source of solar radiation, solar flares, and coronal mass ejections, CMEs, large bursts of solar wind and magnetic fields. These events can have a profound impact on Earth's magnetosphere, causing geomagnetic storms that can disrupt satellite communications, GPS systems, and power grids. The latest data suggests that the Sun's activity is increasing, with some scientists theorizing that the current solar cycle is experiencing a period of heightened intensity. In light of this, international space agencies, including NASA and the European Space Agency, are investing in new solar observation missions to better track the Sun's behavior and predict potential solar storms. The goal is to develop more accurate models of solar activity and its impact on Earth's systems. If we can understand the Sun's behavior on a more granular level, we may be able to anticipate the effects of solar flares and CMEs on our technological infrastructure, allowing for preventive measures and improved resilience. Meanwhile, some researchers are exploring how these solar events may be related to the cosmic disturbances affecting Earth. There is growing interest in the idea that the interaction between solar wind and cosmic radiation may be amplifying the impact of these cosmic phenomena. If these events are interconnected in some way, it could mean that the Earth's exposure to dangerous radiation is increasing, not only due to distant cosmic sources but also due to heightened solar activity. This dual threat could have serious implications for human health, satellite systems, and Earth's overall climate stability. This interconnectedness between solar and cosmic phenomena is just one example of the complex web of relationships that govern the universe. To understand these disturbances fully, scientists must take into account not just the events themselves but also how they interact with one another. This holistic approach is beginning to reshape our view of the cosmos, urging researchers to consider the broader implications of cosmic phenomena on the entire solar system. In response to these concerns, space agencies are also developing new protective technologies for satellites and astronauts. The increased risk of solar radiation exposure and cosmic rays has led to the creation of specialized shielding materials that can block harmful radiation. These materials are already being integrated into the design of spacecraft, space stations, and satellites, providing an additional layer of protection against the dangers of deep space. Additionally, scientists are researching ways to protect astronauts from the long-term effects of radiation exposure. Long-duration space missions, such as those planned for Mars exploration, will require astronauts to spend extended periods in space, far from the protective shield of Earth's atmosphere. To address this, researchers are experimenting with innovative forms of radiation shielding, including magnetic fields, which could be used to redirect harmful radiation away from spacecraft and their crew. These technologies are still in the experimental stages, but they hold immense promise for future space exploration. As we continue to explore the impact of these cosmic disturbances, one thing remains clear: humanity is entering a new phase of our understanding of the universe. With each discovery, we are forced to confront new challenges and rethink our place in the cosmos. While these disturbances present real risks to life on Earth, they also present unparalleled opportunities for scientific discovery. The answers we uncover today may not only help protect our planet from the dangers of cosmic phenomena but could also provide the key to unlocking the deeper mysteries of the universe itself. In the end, the study of these cosmic disturbances is not just about understanding the forces that affect us. It is about coming to terms with the vastness and complexity of the universe. As we continue to explore the unknown, we are reminded that the universe is a dynamic, constantly changing system, full of mysteries waiting to be uncovered. The more we learn, the more we realize just how much we have yet to discover. And as we embark on this journey, we are reminded that we are all part of this cosmic adventure, exploring the wonders of the universe and striving to protect our planet from the forces that lie beyond our understanding. To truly understand the scope and potential impact of these cosmic disturbances, it's crucial to recognize the hidden forces at play in space. One of the most fascinating phenomena that scientists are currently studying is the influence of dark matter and dark energy on cosmic events. Though they remain elusive and largely undetectable through traditional means, these mysterious substances are believed to account for a significant portion of the universe's mass and energy. Recent studies have begun to suggest that dark matter could be playing a role in the way cosmic rays travel through space. In particular, researchers believe that dark matter may affect the trajectory and intensity of high-energy particles from distant galaxies or supernovae. This new line of thinking is challenging traditional models of cosmic radiation and could explain some of the unpredictable behavior of cosmic disturbances that have puzzled scientists for decades. In space, dark matter is thought to form vast, invisible structures that interact with visible matter. These structures could act as gravitational lenses, bending and distorting the paths of cosmic rays, or even redirecting them toward Earth. While still in the early stages of investigation, this theory opens up a host of possibilities, including new ways to predict when and where cosmic rays might have the greatest impact. If dark matter does play a significant role in the propagation of these cosmic disturbances, it could lead to new breakthroughs in astrophysics and cosmology. Meanwhile, another exciting area of research is the role of magnetic fields in the galaxy. Magnetic fields are not just an earthbound phenomenon, they exist throughout the universe, including in the interstellar medium, where they play a critical role in the behavior of cosmic radiation. Scientists have recently discovered that magnetic fields in distant parts of space may be more powerful and dynamic than previously believed. These fields could act as barriers, redirecting cosmic rays away from our planet, or in some cases, amplifying their effects as they collide with the Earth's atmosphere. A particularly intriguing area of study is the relationship between cosmic radiation and the solar wind. The solar wind, made up of charged particles emitted by the sun, interacts with Earth's magnetic field, creating the beautiful auroras we see near the poles. However, the interaction between the solar wind and cosmic rays is far more complex than just visual displays of light. Research is ongoing into how these two forces influence each other, and whether cosmic rays might be affected or even enhanced by solar activity. One recent theory suggests that solar activity could either shield Earth from harmful cosmic radiation or, conversely, amplify its effects. During periods of high solar activity, when solar flares and coronal mass ejections are common, the sun's magnetic field may act as a protective shield, deflecting cosmic rays away from the Earth. On the other hand, during times of low solar activity, the sun's magnetic field weakens, which could leave Earth more vulnerable to cosmic radiation. Understanding this relationship is crucial for future space exploration and even for protecting our technological infrastructure on Earth. In addition to the sun's role, another critical factor in understanding cosmic disturbances is the magnetic field of Earth itself. The Earth's magnetosphere is our primary defense against cosmic rays, acting as a shield that deflects most high-energy particles. However, this magnetic field is not static. It has experienced shifts and reversals in the past, and it continues to fluctuate. Some researchers are studying whether these changes could have an impact on the intensity of cosmic radiation reaching the Earth, If Earth's magnetic field were to weaken, even temporarily, it could allow more cosmic rays to penetrate the atmosphere, with potentially dangerous consequences. One area where these cosmic disturbances could have an immediate impact is on satellite technology. Satellites orbiting Earth are already at risk from space weather, including solar flares and cosmic radiation. These events can damage satellite components, disrupt communications, and even cause complete failures in systems critical to our global infrastructure. As the intensity of cosmic disturbances grows, scientists are working to develop new materials and technologies to protect satellites from radiation exposure. One solution being explored is radiation-hardened electronics, which are designed to withstand the harsh conditions of space. In the long term, space agencies are also considering the potential dangers to human space exploration. If the current trend of increased cosmic disturbances continues, astronauts could be at risk during missions to the Moon, Mars, and beyond. Prolonged exposure to cosmic radiation can damage human DNA, increase cancer risks, and even interfere with the central nervous system. Space agencies are researching new forms of shielding for spacecraft, such as using water, lead, or even the natural geology of planets like Mars to protect astronauts. Additionally, innovative research into artificial magnetic fields could provide a new way to shield astronauts from harmful radiation on long-duration missions. Researchers are also exploring how cosmic disturbances might affect the Earth's atmosphere itself. The increased radiation from space could have significant effects on atmospheric chemistry, potentially leading to changes in weather patterns, ozone depletion, and even an increase in the frequency and severity of storms. While Earth's atmosphere is robust and can absorb a large amount of radiation, the increasing intensity of cosmic disturbances may eventually overwhelm it, resulting in far-reaching consequences for climate systems and human societies. These disturbances could also impact the geophysical processes on Earth. Some scientists are investigating whether the increasing levels of cosmic radiation might influence volcanic activity. The theory is that cosmic rays may play a role in triggering volcanic eruptions by interacting with the Earth's crust. While still speculative, this idea is gaining traction, especially as researchers find correlations between spikes in cosmic radiation and increased seismic activity in certain volcanic regions. Understanding the full scope of these interactions could provide a new dimension to our understanding of both space weather and terrestrial geology. Beyond Earth, there's also the possibility that these cosmic disturbances could impact other planets and moons in our solar system. For example, Mars, which lacks a strong magnetic field and a protective atmosphere, may be particularly vulnerable to the effects of cosmic radiation. Recent missions to Mars, such as NASA's Perseverance rover, have measured radiation levels on the Martian surface, providing valuable data on how these cosmic disturbances could affect future human exploration of the Red Planet. In addition to the potential health risks to astronauts, the impact of cosmic radiation on Martian soil could influence the development of future habitats and agricultural systems. As we look further into the future, the implications of these cosmic disturbances go beyond just our own solar system. These events have the potential to affect interstellar travel, as we begin to consider the prospect of sending probes and spacecraft to distant stars. The vast distances involved would expose our spacecraft to higher levels of cosmic radiation, which could damage both the instruments and the crew. Designing interstellar spacecraft with radiation protection in mind will be a crucial challenge as we take our first steps beyond our home planet. One promising development is the study of plasma propulsion systems. These systems, which use magnetic fields to propel spacecraft, could potentially provide a way to mitigate the effects of cosmic radiation during interstellar travel. By creating a protective magnetic shield around a spacecraft, scientists hope to prevent harmful radiation from reaching the crew and equipment. Though still in the experimental stages, plasma propulsion represents a cutting-edge area of research that could make long-duration space missions much safer. The more we learn about these cosmic disturbances, the more we realize just how interconnected our world is with the universe around us. One area that is gaining increasing attention from scientists is the potential for extraterrestrial life and the implications cosmic phenomena may have on the search for life beyond Earth. For decades, we've been searching for signs of life in the universe, but new discoveries in both astronomy and microbiology suggest that life might not just be confined to our planet. Recent findings in astrobiology indicate that extremophiles, organisms that thrive in extreme conditions, are far more adaptable than previously thought. These microscopic organisms can survive in some of the most hostile environments on Earth, such as deep ocean vents, acidic hot springs, and even in the vacuum of space. As we explore other planets and moons in our solar system, the understanding of extremophiles is influencing where we search for life. Europa, one of Jupiter's moons, has become a key focus in this search. Beneath its icy surface, scientists believe there could be a subsurface ocean, kept warm by tidal heating from Jupiter's gravitational pull. This ocean could harbor the necessary ingredients for life, and the potential for microbial organisms to exist in these extreme conditions makes Europa one of the most intriguing targets for exploration. Similarly, Enceladus, a moon of Saturn, has shown signs of hydrothermal activity beneath its icy crust. Water vapor and organic compounds have been detected in plumes of gas erupting from the moon's surface, further fueling theories that life could exist there. The discovery of complex organic molecules in these plumes has made Enceladus one of the most promising locations for astrobiologists. The search for life isn't just limited to moons within our solar system. In recent years, astronomers have discovered thousands of exoplanets, planets that orbit stars outside of our solar system. Many of these planets lie in the habitable zone of their respective stars, where conditions may be just right for liquid water to exist. The discovery of such planets has opened up entirely new possibilities in the search for extraterrestrial life. But cosmic phenomena could also play a crucial role in these searches. Gamma-ray bursts, for instance, are incredibly energetic explosions observed in distant galaxies. Some scientists have theorized that gamma-ray bursts could have played a role in sterilizing planets within certain star systems. The intense radiation from these bursts could potentially wipe out the chances of life developing on planets in their path. These bursts, though fascinating in their own right, present a clear challenge when considering how likely it is for life to thrive in the universe. Moreover, the discovery of biosignatures, chemical indicators of life, in distant atmospheres is becoming a more prominent focus for astronomers. Instruments like the James Webb Space Telescope are equipped with cutting-edge capabilities to analyze the atmospheres of exoplanets for the presence of gases like oxygen, methane, and carbon dioxide, which could indicate biological activity. As we continue to refine our detection methods, we may soon be able to detect life in its most primitive forms, perhaps not in the way we know it on Earth, but in a form adapted to the conditions of another world. However, as we look outward into space, we also must consider the broader implications of discovering extraterrestrial life. The realization that we are not alone in the universe would fundamentally alter our understanding of our place in it. Beyond the scientific impact, it could have profound philosophical and societal effects. Would humanity be ready to face the knowledge that life exists elsewhere in the cosmos? What impact would this discovery have on religion, ethics, and our understanding of intelligence? One important aspect of this search that ties directly into cosmic phenomena is the Fermi paradox. This paradox revolves around the contradiction between the high probability of extraterrestrial civilizations existing in the vast universe and the lack of any evidence or contact with these civilizations. If there are billions of habitable planets in the galaxy, why haven't we detected any signs of life? Some theories suggest that extraterrestrial civilizations might be avoiding us, either intentionally or unintentionally, due to the dangers of cosmic phenomena like supernovae or gamma-ray bursts. Another potential explanation could be the Great Filter theory. This hypothesis posits that there is a highly improbable event or series of events that prevents civilizations from advancing to the point where they can communicate across interstellar distances. The Great Filter could be the result of cosmic disasters, such as asteroid impacts or supervolcano eruptions, or it could be a natural barrier that life must overcome to survive long enough to develop advanced technologies. This theory raises important questions about the resilience of life in the universe and whether humanity has already passed through the filter, or if it still lies ahead of us. In addition to these theories, there's another intriguing possibility that is emerging from the study of fast radio bursts, FRBs. These mysterious, high-energy phenomena occur sporadically in distant galaxies and release enormous amounts of energy in a fraction of a second. While the origins of FRBs remain unknown, some researchers have speculated that they could be signals from extraterrestrial civilizations. The possibility that these bursts might be artificial in origin has led to a new avenue of investigation in the search for intelligent life in the universe. Whether FRBs are natural or technological in nature, they demonstrate the incredible complexity of the cosmos and the many unknowns that scientists are still working to understand. While the search for extraterrestrial life is one of the most exciting frontiers in modern science, it also reminds us of the vastness and mystery of the universe. As we study cosmic phenomena and their effects on our planet, we are also learning about the broader context in which life, both ours and potentially others, exists. These cosmic events, from solar flares to gamma ray bursts, are not just phenomena happening in distant galaxies. They're part of the intricate, interconnected web of the universe that shapes the conditions for life, survival, and discovery. Let's shift gears and explore another intriguing possibility, something that could be linked to the rare cosmic phenomenon affecting Earth: gravitational waves. These ripples in space-time were first predicted by Albert Einstein over a century ago as part of his theory of general relativity. They're produced by some of the most violent and energetic processes in the universe, like the collision of black holes or neutron stars, and are traveling through the fabric of space itself, causing tiny distortions in the distance between objects. For most of human history, gravitational waves remain theoretical, a mathematical curiosity without any experimental evidence. But in 2015, a team of scientists made a groundbreaking discovery. For the first time ever, gravitational waves were detected by the Laser Interferometer Gravitational Wave Observatory, LIGO. The waves were produced by the merger of two black holes over 1 billion light-years away. This discovery confirmed Einstein's theory and opened up a whole new way of observing the universe, unlike anything we've done before. Why is this relevant to the cosmic phenomenon affecting Earth? Well, in the grand scheme of cosmic disturbances, gravitational waves might be one of the least understood and most underexplored areas of study. While we've been able to detect gravitational waves, we still don't fully understand how these events might interact with our planet, or even what their full implications could be for the future of Earth. Scientists believe that as we continue to refine our methods of detecting and understanding these waves, we may start to notice more subtle interactions between gravitational waves and the Earth's environment. Gravitational waves, although faint, have been traveling through space for billions of years. As they pass through Earth, they cause microscopic distortions in the fabric of space-time. On their own, these distortions are minuscule and hardly detectable by the naked eye. But if the frequency or intensity of these waves increases, could they have a more profound impact on Earth? Could they affect the structure of our planet in ways we don't yet understand? Researchers are beginning to consider how gravitational waves could influence things like Earth's atmosphere, tectonic activity, and even our planet's magnetic field. For example, could a particularly strong gravitational wave cause enough stress on Earth's crust to trigger earthquakes or volcanic activity? There's no direct evidence of this yet, but the idea is being taken seriously, as some scientists point out that the immense energy released by gravitational waves could have far-reaching effects on the Earth's geophysical processes. What if these waves were part of a much larger cosmic phenomenon? Something that could be interacting with other forces in space to create a cascade of effects on Earth's environment. For instance, gravitational waves could potentially interact with solar winds or even the cosmic rays we've discussed earlier, compounding the existing environmental and atmospheric disturbances caused by those other forces. This could lead to an overall amplification of effects, creating more unpredictable and extreme weather patterns, shifts in magnetic poles, or unforeseen challenges to satellite communications and GPS systems. At the same time, the detection of gravitational waves could also offer a new window into space, one that allows scientists to study cosmic events that were previously invisible to us. This includes the study of phenomena like black holes and neutron stars, which are typically undetectable through traditional telescopic methods. These objects, with their intense gravitational fields, are the sources of the most powerful gravitational waves in the universe, and they provide a unique opportunity to explore the deepest mysteries of space. More recently, astronomers have been looking at the potential connection between gravitational waves and the fabric of dark matter. Dark matter, an invisible substance that makes up around 27% of the universe, remains one of the most puzzling phenomena in modern science. What if the interaction between gravitational waves and dark matter could reveal new information about the universe's unseen forces? Some scientists have proposed that these waves could act as a bridge, allowing us to observe dark matter in ways that were once thought impossible. If gravitational waves do indeed offer a direct line of inquiry into dark matter, it could radically transform our understanding of the cosmos. Moreover, gravitational wave astronomy is in its infancy. LIGO and other observatories like Virgo and Cagra are just beginning to unlock the secrets of the universe by detecting and analyzing gravitational waves. And with more observatories set to come online in the coming decades, the ability to detect more frequent and higher-energy gravitational waves could lead to the discovery of previously unknown cosmic events, offering scientists a front-row seat to the most violent and mysterious events in space. This brings us back to Earth's current experience with these cosmic waves. The sheer energy behind a collision of two black holes, for example, can release more energy in a fraction of a second than our Sun will emit in its entire lifetime. While these events happen far away from Earth, the potential for gravitational waves to affect our planet is a reminder that the universe operates on scales beyond our comprehension. It's only through breakthroughs in science and technology that we've even begun to scratch the surface of understanding how these cosmic forces affect us. The most recent developments in gravitational wave research also raise the possibility of detecting future cosmic phenomena. For instance, upcoming observatories might allow us to track these waves in real time, giving us advance warning of catastrophic cosmic events. Imagine receiving a warning about a massive stellar collision or the merger of black holes billions of light years away, events so powerful that they could send ripples across the fabric of space-time itself, subtly affecting Earth in ways we cannot predict. One of the most intriguing theories involves the concept of multiverses, the idea that our universe is not the only one, but part of a much larger, perhaps infinite, collection of parallel universes. Each of these universes could operate under different laws of physics, offering the potential for an entirely different version of reality. Some researchers believe that gravitational waves or certain types of cosmic radiation could be the key to detecting these parallel universes, or at least the evidence of their existence. If true, this could open the door to a new realm of possibilities, including the potential for interdimensional interactions. What does this have to do with the rare cosmic phenomenon affecting Earth? If parallel universes exist, then it's possible that cosmic forces, like gravitational waves, could be causing ripples between dimensions, disturbances that might affect the structure of our own universe. Imagine, for instance, a gravitational wave originating not just from a distant black hole merger but from an event occurring in a neighboring universe. Such waves might be so subtle that they pass undetected, but their effects could ripple through the fabric of space-time, influencing everything from the behavior of dark matter to the movement of galaxies. Even more remarkably, they could have the potential to alter the laws of physics as we know them, leading to unexpected changes in fundamental constants, or even new forces of nature. To further build on this idea, consider the field of quantum mechanics, where some physicists speculate that particles could exist in multiple places at once, or that actions in one dimension could affect another. If this truly is the case, then events occurring in parallel universes could, in theory, have observable effects on our own. Researchers have even begun to speculate that certain cosmic events, such as gamma-ray bursts, supernovae, or even the mysterious cosmic rays, might be influenced by or emanate from these parallel universes. While much of this remains speculative, some scientists are beginning to explore how quantum mechanics and multiverse theories might help explain some of the strange phenomena we are seeing in our universe. If gravitational waves or other cosmic disturbances are interacting with higher dimensional forces, we might be able to detect anomalies that don't quite fit with our current understanding of physics. These anomalies could manifest in the form of unusual radiation patterns, erratic gravitational wave readings, or even sudden shifts in the cosmic background radiation. The implications of interdimensional interactions are staggering. Not only would they drastically change how we think about space-time and the structure of the universe, but they could also provide answers to some of the deepest questions we've been asking for centuries. For example, could the dark matter that we observe in our universe actually be a form of matter from a neighboring dimension? Could the mysterious dark energy responsible for the accelerated expansion of the universe be the result of forces from outside our own reality? If these dimensions are influencing our universe in ways we cannot yet comprehend, it could provide the missing pieces to our understanding of the universe's most puzzling phenomena. Moreover, the study of quantum entanglement, where particles are mysteriously connected, regardless of the distance between them, could be another key to unlocking the secrets of interdimensional travel. If we can find ways to manipulate these entangled particles, it could eventually lead to technologies that allow us to interact with other dimensions or even travel between them. While this may sound like science fiction, there are scientists today who believe that the fundamental principles behind quantum entanglement could eventually lead to breakthrough technologies that radically change our understanding of space, time, and reality itself. This brings us back to the cosmic phenomenon affecting Earth. While scientists are still unraveling the mystery of these disturbances, the potential connection to interdimensional forces or multiverse activity cannot be ruled out. As our technology advances, it's possible that we may begin to detect signs of interaction between our universe and others, and the implications of this discovery could be beyond anything we can imagine. Could this rare cosmic event be the first clue to a much larger, universe-spanning phenomenon that is altering the very course of time and space? In addition to interdimensional theories, another avenue of exploration is the role of gravitational lensing in the study of cosmic events. Gravitational lensing occurs when a massive object, such as a galaxy or black hole, bends the light from objects behind it, allowing us to see those objects in ways that would otherwise be impossible. It's like looking through a cosmic magnifying glass. This phenomenon is not only an important tool for astronomers to observe distant galaxies and stars, but it may also provide insight into the rare cosmic disturbances affecting Earth. Could gravitational lensing be revealing new, previously invisible events or structures in the universe that are contributing to the disturbances we're experiencing on Earth? For example, it's possible that a massive, unseen object, perhaps a dark matter concentration or an exotic form of energy, could be warping space-time and affecting the path of light in ways that we can only begin to understand. As astronomers continue to use gravitational lensing to study the universe, they might uncover new information about cosmic events that are influencing Earth in ways we've never considered. With all of these groundbreaking theories and discoveries unfolding before us, it's clear that the rare cosmic phenomenon affecting Earth is part of a much larger cosmic tapestry. Whether it's the result of gravitational waves, interdimensional interactions, or the influence of unseen objects in space, our understanding of the universe is on the brink of transformation. The future of space exploration and cosmic science holds more promise than ever before, and as we continue to push the boundaries of human knowledge, we may soon uncover truths that challenge everything we thought we knew about the universe.